Hello, my name is John Hooker, and I'm the engineering manager here at Statistics and Control Inc. And today I'm going to talk about our digital oilfield solution, specifically with condition monitoring. So just to give a little background on our company, we were founded in 2005. We have offices all over the world, have a pretty large global portfolio. One of the nice things, we're always growing technology, we're always growing with different projects, and we're always growing with personnel. We have a couple of different product lines. We have our OptiRamp software, which this is our advanced process control software where we can simulate in the power and process real-time predictive analytics and simulation. We can virtualize and optimize just about any process in the oil and gas industry. And the whole idea behind this simulation is to reduce costs and increase stability and reliability. And then the other aspect of our company is turbo machinery control. So we develop applications for conventional PLC control, and one of the things that sets us apart from a lot of the other companies is we're OEM neutral. So we are able to do control in PLCs such as Siemens, Honeywell, Allen Bradley. We don't really have a preference for it, and we have experience in them all. But today we're going to focus mostly on OptiRamp. And so here this just kind of goes to show the different global locations that we have throughout the world. And as I said, we're a pretty global company, and we tend to have projects in and around just about every country that we work in. Here's just a small example of the customers that we have and have done work for. So we range from a lot of the large oil and gas companies all the way down to smaller companies that don't have quite the manpower or the budget that a lot of the big companies do. So this is just a couple ways to look at OptiRamp in industrial use. So here we're using it in the oil and gas industry, and we use it in all three sections of it, whether it be upstream, midstream, or downstream. We've used it in power utility for traditional power plants, geothermal power plants. We've used it in chemical plants for chemical refining. We've used it in water utilities for water distribution and pipelines. So there's quite a lot of where OptiRamp can go and what OptiRamp can do. And the whole purpose behind that is OptiRamp uses the same core algorithms and the same software applications across all industries. And we're able to support a lot of different models for rotating equipment for doing that predictive maintenance and statistical analysis in real time. So what people are using OptiRamp for condition monitoring for is they're looking at minimizing energy use, they're looking at minimum downtime for machines, and also trying to help save on costs. A lot of that's tied to minimum energy use. So, and the way that we do that is we're able to track KPIs of real signals and calculated signals. So what we do with OptiRamp is we first model the either process or model the individual unit, and with these models we have models for artificial lift systems, gas turbines and generators, compressors, pumps, motors, different oil and gas wells, pipelines, steam systems. We can model cogeneration. Like I said, just about anything and everything that you can find in the power industry and the utilities industry, as well as the oil and gas industry, we're able to model that process and simulate it. And so the whole purpose behind the simulation is to track that capacity and operational planning, help rapidly assess unscheduled changes in operation, predict efficiency of rotating equipment, track degradation of equipment, and monitor runtime and downtime. And also we even have a virtual logbook as well to kind of centralize a lot of that data and be able to help with lots of different assets all around the world. All of our customers tend to do it differently, but they still have the same value stream and use the same OptiRamp tools in that. So here, this is just kind of a little bit of different aspects for OptiRamp condition monitoring, and this is what some people have done. They've done a lot of electrical consumption calculations, a lot of reduced energy consumption. The whole idea is to track that performance of the equipment, predict equipment efficiencies, let operators know, yes, this pump is running much better than this other pump. Okay, why isn't this pump running not quite as well? Track equipment degradation. Instead of getting an emergency shutdown on a compressor, they're able to see, hey, this compressor is actually running not quite as efficient, so let's go ahead and shut it down, get it maintained, and then bring it back up. So it helps with less emergency shutdowns, and with that comes the improvement of process stability, and it helps you hit your target quite a lot better. And the whole idea behind this is to reduce downtime. So with condition monitoring, one of the nice aspects of our software is there's a lot of different calculations, there's a lot of different things that we have. We have a very detailed model of each individual unit, as well as a very detailed process modeling system. And so for the centrifugal machines, you can see that we can help track a lot of these deficiencies and help calculate when, say, for example, something's cavitating, you have rotating mass imbalances on there. You have coupling defects, gear defects, especially for electrical motors, whether you have current overload, phase mismatches, distortions of relative position of rotor and stator axes, squirrel cage defects, all of these things, as long as data is coming in and we're calculating how it's operating, we can be able to help detect some of these aspects that are going on in all of these, all of your different turbo machinery equipment. And one of the nice aspects about it is that you have the ability to have all that information at your fingertips, and the whole idea behind this is to provide actionable information for your operators. So the main purpose is when they see current overload, you know that you have a current overload, and you're not guessing at just, hey, the voltage is over, so you need to know what it is. So we can put precise notification messages in order to let the operator know specifically what they need to do in order to make that effective change in the system. So like I said, the whole step behind it is to model the process. So we model pumps, pipes, pipelines, control blocks, gate valves, engines, motors, gas turbines, steam turbines, pretty much you name it. Like I said, we are able to model it, and from that model we can then connect it to real-time values and be able to get that process going and show that dynamic behavior in the process. One of the nice things is we have a large operational range to help reliably replicate the process and show those changes in operating conditions, from whether you bring wells online or offline, whether you bring pumps online or offline, whether you bring different individual units online or offline. And with that, we can help predict the energy cost as well as how efficient your operation is going to be running in the future. So here, this is just an example of some of the energy consumption calculations that we've done. We track energy usage by wells, so we're able to track that electrical consumption. We're able to track the cost of operating at each well and calculate that profit at each well also. So this is just some of the simple calculations that we can set up inside our software, and it makes it easy for the user to be able to grow those calculations or be able to adjust those calculations however they see fit for. And one of the ways that we connect it real-time data is through our virtual tag server. So our system, the model, you build the model and then you simulate what's going on in the process, and then the virtual tag server connects all that live data. So it's getting streaming data from OPC, ODBC, Modbus standards, even web clients as well. It just depends on how you want to set it up, but the whole idea is to collect data from multiple sources into a general data set, and from all of our different calculations we're able to provide data to local and even remote clients. We're able to store data at high speeds as well, so that's another nice aspect of our own database and our own virtual tag server, is that once we collect all the data, we're the ones who process it and store it. And so that way you have all the data at your fingertips, whether it be on site or even in the cloud. Here, this just shows an example of our web analytics, and this is where a lot of our users view data from. So this web analytics is a customized hierarchy to view data from OptiRamp and VTS sources, and it helps visualize everything that's going on in the process. In this example, we're simulating an entire digital oil field. From the left side here, you could see that we have the wells and well pads, and then the gathering system network all the way to separation, and then the transportation network all the way to the power station that it goes to, all the way to the liquid oil transportation where it goes to refinement, and then even water injection all the way to water storage as well. So we can simulate from right from the beginning all the way to the end. And the whole idea with this web analytics is to build those KPIs that are important to you and to be able to track and know what's going on inside your process. So here, this is just another example of the different unit performance that we have. So we display the bump curve in real time. We can build different types of curves that you guys want to track in real time. Here, this is an example of an IPR curve for a oil well, but we can build a lot of these real-time curves in there, and we've already built quite a lot of real-time images in our system. And another thing that we can do is tackle the alerts, where we can create alerts for source data. So if a signal goes out of range or is expected bad quality, we also do quite a lot of statistical analysis based on our historical data that we have. So we can take a look at the efficiencies. Is it running? Is it slanting downwards? Is the efficiency improving? If it is, then it starts to get into, okay, well, what are the changes that we made to help improve that efficiency, or help to, or even if it's, say, for example, it's going the other way, what's going on that is causing that bad efficiency in that unit. And so our notifications shows alerts from all projects. We can even have event tables right in Web Analytics and in reports that shows relevant alerts for the current display, and we'll actually see examples of this as we get to an example. So here is our example customer use case. We actually helped build a decision support center that was a digital oil field project. So there were 3,500 production wells, 1,200 injection wells, and 11 oil processing facilities, about 300 kilometers of oil transportation network, and about 6,000 kilometers of the liquid transportation gathering system. And so we were able to simulate this entire thing in there. Specifically, this was an electrical submersible pump. So what they wanted was, they specifically wanted KPIs to track how well their submersible pumps were doing downhole, and to build that decision support center. So we were able to optimize the entire oil field essentially, and calculate those allocation factors, reducing number of devices to understand flow behaviors and distribution flow lines. Another nice aspect is, instead of using a software for, say, for example, just the downhole aspect in that submersible pump, using software to simulate the gathering system, using an optimization software to optimize everything, it was all in one package. And so with that, we were able to grow the growth of oil and gas production from 1% to 5% in different fields. And the biggest thing is, we were able to reduce well site visits by about 30% and reduce well downtime by about 10%. And then also, one of the nice aspects too is, we were able to increase that equipment overhaul life by about 5% as well, and also track and show those losses. So there's quite a lot to show with our software. So one of the things that we're going to do is, we're just going to go ahead and take a look at the web analytics portion of it. And so here you can see this is what the customer is actually looking at. So we have a production overview and an injection overview, and we can have just about any type of graph or chart available, and every customer wants to have their own different dashboards and KPIs to view. And so this is just kind of specific towards one of the digital oil fields that we built. And so here, this just takes a look at that digital oil field operation. So like I said, a lot of different meters, bar charts, trends, different real-time tables that we have to show everything. And we're feeding data into it through a Kepler server right now. And so this shows the overall field that we're simulating. So it's a little bit smaller than what we did for this actual project, but here you can see the well pads and some of the different issues that they have going on here. You can see the different transportation network that we have in the gathering system in there. And then what we're going to do is, we're just going to skip on down to the individual well unit, because that's where we start getting into that real condition monitoring for the system. And so here you can already see that in this image we have already our notification on there. So normally we can take a set point and have either set by alarm or the severity of the different alarms. And when it goes over a certain threshold, we can display this notification saying, hey, you have a lot going on with this specific well. So when you have 2,500 wells, it makes it easy to drill down to see which wells are causing a problem and which ones are. And on here you can see this real-time pump curve, and you can see it start to move occasionally as data is being fed into it, and as we're constantly calculating how the well is doing and how the pump is operating. One of the notifications I see right here is we're actually getting a little too high in our allocation factor. So we just actually have a number in there where it crosses a certain threshold. So if it gets above 1.5%, then we say, okay, let's go ahead and send a alert message to that. And then just coming down and looking here, we're actually tracking different KPIs. So what we're doing with the electrical submersible pump temperature is we're actually taking that historical data, seeing if we have any outliers in there, seeing how the system is operating currently, and if there's a lot of variability in the system. Because again, one of the things is we like the process not to change all that much, and we can let the user know, hey, you happen to have a large amount of variability in the system. And then a couple of other things, and we do the same thing for the current that is happening right now. So just a couple other things that we're calculating is it's been running for about 6 days. Our failure rate is only at about 6.67%, so they had a specific way they wanted to calculate failure rate. We have that in there. And then percent degradation, they also wanted to calculate how much it's degradation in the system in there. So we're able to calculate that. Here, this is just a general well test that we take a look at, but we won't worry too much about that. Here is our decline analysis that we are doing, and currently right now this is situated on the amount of oil flow that's in a well, but this decline analysis can be applied to, say for example, unit efficiencies and let you know how much they're how efficient they are. They can also be applied to different calculations in the system to let you know whether they're increasing too quickly or decreasing too quickly, and that's where a lot of that statistical analysis comes in from the data that we collect. And so here you can see that on today we have about 302 barrels flowing per day, and our estimated guess 60 days from now is it's going to be about 235. So it's hasn't really or it's not decreasing enough to cause an alarm. And that's another thing that we can do is we can set alarms for different ways that it will decline or decrease in that. And then here this just shows an example of the different curves that we can create in our system and how we want to do that. And then at the bottom here, what we have is we have different notifications. So as you can see, I already talked about the water allocation factor is really high for the system. We also have a couple notifications here about outliers. So what our system does is it creates a kind of a mean, and we can deploy how type of sigma for how far away you are from the bell curve. So it basically creates a bell curve out of the data and then lets you know if you have any outliers for it. And in this specific example, they were having trouble with their current and their voltage, and a lot of times the voltage will either spike and that will cause issues with the pump. And so we're trying not to have too many issues with that. And then here, this just shows that right now it's operating at a low efficiency, and so we just have please check if maintenance is needed. So these are all different types of things that we can apply to our application, and will help increase that profit and reduce downtime with that. So with that, we'll just hop back here to our conclusion. And so we use a spectrum of analytics to help optimize well production. The whole idea is to help reduce energy and maintenance costs, extend that life cycle of your rotating equipment, and improve the availability and reliability of rotating equipment. And so we combine our simulation with our web applications, and we help build that domain knowledge and help increase that operational intelligence. And if you have any questions, don't hesitate to contact sales@OptiRamp.com. That's all for me today, and I thank you and appreciate your time.